Hi everyone, welcome back. This is the 18th lecture in IE 451, Engineering Economy. Okay, so here's the first problem that we are going to solve for today from end of chapter 5, problem number 5-18. So IBP Incorporation is considering establishing a new machine to automate a meat packing process. The machine will save $50,000 in labor annually. The machine can be purchased for $200,000 today and will be used for a period of 10 years. It looks like this typo. It has a service value of $10,000 at the end of its useful life. The new machine will require an annual maintenance cost of $9,000. The corporation has a minimum rate of return of 10%. Do you recommend automating the process? Okay, so we'd like to know if the net present worth is non-negative. This is the problem number 5-18, right? We know that net present worth can be computed by present worth of benefit minus present worth of cost, right? So how do you get the present worth of benefit? The machine will save $50,000 in labor annually, and for the next 10 years, right? And the end of its useful life, the service value is how much? Is $10,000. So all of those are the benefits. So the present worth of benefits would be $50,000 annually. So it can be converted to the equivalent present sum. So 50,000 times P given A, 10% over 10 years, right? And at the end of 10 years, there is a service values of $10,000. So 10,000 times P given F, 10% over 10 years, right? So let's get these table values. 10%. So we need to look for page 613 of our text. P given A over 10 periods, 6.145. What about this? P given F over 10%, over 10 years, 0.3855. 3855. Okay. So how much is that? Okay. This is going to be $305,500. Okay, so this is your present worth of benefit. Now let's compute the present worth of cost. Okay, present worth of costs. So here, the new machine can be purchased for how much? $200,000 today. And it will require an annual maintenance cost of $9,000 for the next 10 years, right? So all of this is going to be the present worth of cost. It's going to be $200,000 today plus $9,000 of annual maintenance cost. So P given A, 10% over the next 10 years, right? So how much is this? P given A over 10 periods, 6.145. 6.145. So how much is this? It's going to be 255 $1,305. Oops, I think I've copied the wrong value here. Let's recompute this. It's got to be wrong here. I'm sorry, but this gotta be $311,105. So what is your net present worth? Present worth of benefit, which is this, minus present worth of cost. So here you have net present worth is $311,105 minus $255,305. From my previous calculation, this is going to be $55,800. Okay? And because the net present worth is positive, this process should be automated. Okay? Okay. So next problem that you are going to solve is a little modification of problem number 5-23. Okay. So a student has a job that leaves her with $250 per month in disposable income. She decides that she will use the money to buy a car. Before looking for a car, she arranges a 100% loan, whose terms are $250 per month for 36 months at 18% annual interest. Then, what is the maximum car purchase price that she can afford with her loan? So this is the problem number 5-23. Small modification of it, right? So basically we want to find the present sum of money, P. And what about the interest rate? Interest rate is %18 annual interest for 36 months, right? So it's going to be 1.5% monthly. Okay. 18% divided by 12 months becomes 1.5% monthly. Okay. And the interest period would be 36 months. Is that right? And what is the value A in this case? $250. The monthly payment she can afford to is $250, right? Okay. So how'd you get this present sum P? 250 times P given A, 1.5% over 36 periods. Do we have a table value for this? Let's check it out. Yeah, yes, we do. Okay, 1.5% over 36 periods. P given A, which is 27.661. 27.661. So how much is this? Okay, it's going to be $6,915. Okay. This is the answer. That is the maximum car purchase price that she can afford with her loan. Okay, next, let's consider another small modification of problem 5-24. The student in problem 5-23 which is the previous problem, right? This one. The student in the previous problem finds a car she likes, and the dealer offers to arrange financing. His terms are 12% interest for 60 months and no down payments. The car's sticker price is $12,000. Can she afford to purchase this car with her $250 monthly disposable income? So each one of you might have the very similar situation like this, right? So the sticker price of the car, okay, let's say this is the problem number 5-24M. The sticker price of the car is $12,000. Okay, and what is the interest rate? It's 12% for 60 months. Okay, so he's going to charge 1% interest rate, right? Monthly interest rate. Because 12% divided by 12, because there are 12 months in a year, which becomes 1% monthly interest rate. And in that case, N becomes 60 months, right? So using all this given information, you can get the monthly payment. Her monthly payment which is $12,000 times A given P, right? And 1% over 60 periods. So is that correct? Okay. So the sticker price is $12,000 and the dealer offers 12% interest rate for the next 60 months. So the interest rate is 1% monthly for the next 60 months. And in such case, her monthly payment can be obtained by $12,000 times A given P, 1% over 60 periods. Yeah, that looks okay to me. Okay, what about this table value? 1% over, okay, A given P over 60 periods. That is 0.0222. 0.0222. So how much is that? Okay, this is the $266. Now, what you need to do is to compare this amount of money, $266, with $250, right? That is the monthly amount that she can afford to with her loan, right? So because this amount of money is greater than what she can afford to, which is $250. So she cannot get the new car, right? So she cannot afford the new car. That's the answer for problem 5-24M. Okay. Unfortunately. Okay, then what about next problem? Okay, let's solve problem 5-32. Two alternative courses of action have the following schedules of disbursements. Based on a 6% interest rate, which alternative should be selected? So for option A, a present worth of cost is $1,300. And for option B, how do you get the present worth of cost? As you can see here, this cash flow has a uniform amount of changes each period, right? Each period has been declined by $100, right? So, okay. This is the problem number 5-32. For option B, this given cash flow can be broken into two components, one for the uniform annual series of 100 and another for an arithmetic gradient series with g equals 100, right? So for option B, we're going to have these two cash flow. Zero, 1, 2, 3, 4, and 5. Okay. So we have take out $100. Then we have a uniform series of A. So let's set the present sum of P prime at the end of period 0. And what is left over? If you take out $100 from each period here, at the end of period 2, we have 100, period 3, 200, period 4, 300, and period 5 we have 400. So we have arithmetic gradient G equal to 100. Actually it's negative 100, right? Okay. And let's set P double prime at the end of period 0 here. Then for option B, the present worth of cost for option B would be 100 times this one, P given A, 6% over 5 periods. Right. And then what about this cost? It's going to be 100 times P given G, 6% over 5 periods. Okay. You know, because we are calculating present worth of cost, not the present worth of benefit, you should not put negative sign here. Okay. So what is those table values? We are looking for 6% interest rate, P given A over 5 periods. This is going to be 4.212. And P given G over 5 periods, 7.934. Okay, so how much is that? This is $1,215. That is the present worth of cost for option B. And we know that the present worth of cost for option A is $1,300. So if you compare these two numbers, you can make the conclusion, right? To minimize the present worth of cost, you've got to choose option B, right? Because it's going to cost you less. Okay. The next problem that we are going to solve is, what about 5-36? Two different companies are offering a punch press for sale. Company A charges $250,000 to deliver and install the device. Company A has estimated that the machine will have maintenance and operating costs of $4,000 a year and will provide an annual benefit of $89,000. Company B charges $205,000 to deliver and install the device. And Company B has estimated maintenance and operating costs of the press at $4,300 a year, with an annual benefit of $86,000. Both machines will last 5 years and can be sold for $15,000 for the scrap metal. Use an interest rate of 12%. Which machine should your company buy? Again, using the present worth analysis we may provide the answer. So let me first write down the problem number. We are working on problem 5-36. Okay. So again, we are going to use present worth analysis technique. So net present worth can be obtained by present worth of benefits minus present worth of costs. Okay? So first, for company A, the net present worth would be the negative first cost, which is $250,000, right? Plus annual benefit. Annual benefit is $89,000, right? And this annual benefit should be converted to the equivalent present sum. So you need to multiply by P given A, and here 12% of interest rate over 5 years, right? And there is a service values. How much is that? So both machines can be sold for $15,000 after 5 years. So the salvage values of $15,000, and this future money can be converted to the equivalent present sum of money. So P given F, 12% over 5 periods, right? Is that all? No, you need to consider the maintenance and operating cost, which is $4,000. So negative $4,000 times P given A, right? 12% over 5 years. So that's going to be your net present worth for machine A. So what is these table values? We are looking for 12% of interest rate. So you need to look for page number 614 of our text. P given A over 5 periods is 3.605. 3.605. P given F 0.5674. And P given A 3.605. Is that right? Okay. So how much is that? Okay, this is going to be $64,936. So this is the net present worth amount for company A, from company A. What about the present worth of machine that is provided by company B? The same way, the first cost, which is $205,000, so negative $205,000 plus annual benefit of $86,000. So multiply by P given A, 12% over 5 years, plus the salvage values after 5 years, which is $15,000, P given F, 12% over 5 periods, minus annual maintenance and operating cost, which is $4,300, right? So P given A, 12% over 5 periods. So all these three factor values are identical, right? So how much is that, the net present worth? Okay, that's going to be $98,040. So by comparing these two numbers, net present worth for machine A and net present worth for machine B, what is your conclusion? You have to choose machine B, machine from company B, right? Because it has a greater net present worth. Okay. Then what about problem number 5-35? Wallace Construction Enterprises is investigating the purchase of a new dump truck. Interest is 9%, and the cash flows for two likely models are given in this table. Okay, that includes first cost, annual operating cost, annual income, service values, and the useful lives for both models A and B. Okay, and we are required to answer these two questions. Question A, using the present worth analysis, which truck should the firm buy and the reason why? And question B, before the construction company can close the deal, the dealer sells out of model B and cannot get any more. In such case, what should the firm do now, and again provide the reason why. So we are solving problem 5-35. So again, we are required to use the net present worth analysis. So net present worth would be present worth of benefits minus present worth of costs. Okay? So for the model A, net present worth would be the negative first cost minus annual operating cost plus annual income plus service values after 10 years, right? So for model A, net present worth is the negative first cost $50,000 plus minus annual operating cost, which is 2,000 times P given A, and we're going to use interest rate of 9% over 10 years, right? And the annual income of $9,000, P given A, 9% over 10 years, right? And the service values after 10 years, which is $10,000 times P given F, 9% over 10 years, right? After 10 years. So let's get these table values. 9%. So you need to look for page numbers 612 of our text. P given A over 10 periods, 6.418. 6.418. Right? P given A. Okay. And P given A 6. Okay, this is the same. 6.418. And P given F is 0.4224. 0.4224. So how much is that? Okay, this is going to be negative $850. Okay. What about model B? For model B, the net present worth would be negative first cost, negative $80,000 minus annual operating cost of $1,000 P given A, 9% over 10 periods, plus annual income of $12,000, again multiplied by P given A, 9% over 10 periods, and then salvage values after 10 years, $30,000, P given F, 9% after 10 years. Okay. So we're going to use the same table values, right? So how much is that? Okay, this is going to be positive value, positive $3,270. So the question A is using present worth analysis, which truck should the firm buy and why? Obviously, the firm should buy the Model B trucks, right? They should buy Model B because it has a positive net present worth value. For Model B, it has negative net present worth. Okay? So Model B should be purchased because it provides positive net present worth. How about question B? Before the construction company can close the deal, the dealer sells out of Model B and cannot get any more. What should the firm do right now and why? Okay, then how do you answer? Here's the situation. Originally, both models were available. But right now, the Model B is not available anymore. So only choice you have is go with Model A. And do you really need to do? No. Because the net present worth of Model A is negative, right? So it is better to do nothing or look for another alternatives if possible. Okay? So if Model B is not available, it's better to do nothing. Okay? Because Model A provides negative net present worth. Okay? So maybe for question B, I would do nothing. Okay? Because model A provides a negative net present worth. Okay? Okay, then looks like this would be the last problem for today. The problem number 5-42. So a consulting engineer has been engaged to advise a town how best to proceed with the construction of a 200,000, I believe this is cubic meter water supply reservoir. Sorry, I should have to use superscript of 3. Okay, since only 100,000 cubic meter of storage will be required for the next 25 years. An alternative to building the full capacity now is to build the reservoir in 2 stages. Initially, the reservoir could be built with 120,000 cubic meters of capacity, and then 25 years hence, the additional 80,000 cubic meters of capacity could be added by increasing the height of the reservoir. Estimated costs are summarized in this table. Okay. If interest rate is computed at 4%, which construction plan is preferred? Okay, because it's hard to see from the screen, let me draw the table again. So problem number 5-42. Okay. So first information is about if the reservoir is built in 2 stages. Okay. And here's construction cost. And here's annual maintenance cost. Okay. For the first stage, which is about 120,000 cubic meters, the construction cost will be 14 million and 200 $200,000, and annual maintenance cost would be $75,000. Okay. For the second stage, which is about 80,000 cubic meters, the construction cost would be $12,600,000, and annual maintenance cost are required as $25,000. Okay. And if the reservoir is built full capacity right now, so build full capacity right now, then the required construction cost would be $22,400,000, and annual maintenance cost would be $100,000. Okay. Of course, it's going to require 200,000 cubic meters of reservoir. Okay, at once. And we are going to use 4% of interest rate. Okay. So we are required to compute the present worth of cost for a 25-year period, 25-year analysis period. And note that in both cases, the annual maintenance is $100,000 per year after 25 years. So after 25 years, all the costs are identical. So for the single stage construction, for single stage construction, we just need to consider one time of a construction cost and annual maintenance cost for the next 25 years, right? So for the single stage construction, the present worth of cost would be one time of construction cost, which is $22,400,000 plus $100,000 of maintenance cost for the next 25 years. So it should be converted to the equivalent present sum of money. So you need to multiply by P given A, 4% of interest rate over 25 years, right? So how much is this factor value? So we are looking for 4% P given A over 25 periods. That is 15.622. 15.622. So how much is this? Okay, it's going to be 20 million and $98,000. Okay. What about the present worth of cost for two-stage construction? Present worth of cost. For this option, two-stage construction, we need to consider a construction cost of $40,200,000 right now, and annual maintenance cost of $75,000 for the next 25 years. And additionally, the construction cost of $12,600,000, sorry, at the end of 25 years. Okay? So it's going to be $14,200,000 plus $75,000 for the next 25 years. So it's got to be converted to the equivalent present sum of money. So multiply by P given A, 4% over 25 years. And then also you need to add additional construction cost, which is $12,600,000. And this future sum of money will be converted to the present equivalent present sum of money. Excuse me. So got to be multiplied by P given F, 4% over 25 years. And because we noticed that for both cases, the annual maintenance cost would be $100,000 per year after 25 years. So after 25 years, all the costs are identical. So you don't need to include the annual maintenance cost after 25 years. Okay? So how much is that? P given A. This is also same as 15.622, right? And P given F over 25 periods is 0.3751. 3751. So how much is that? This is the 20 million and 98. Hold on a second, please. $98,000. Well, I think I copied the wrong value earlier. For the single stage construction, it's got to be $23,962,000. Okay? Sorry. So if you compare these two values, one for the single stage construction, another for two stage construction, you will notice that we need to choose two-stage construction because it provides the smaller number of cost values. Okay, smaller amount of cost values. So you got to go with the two-stage construction option. Okay, so this is all for today. And I believe we're going to spend probably 2 more hours to solve end of chapter 5 problems. And then we're going to move on to next chapter, chapter 6. Okay? Okay, thank you. We'll see you next time. Bye-bye.